Welcome to another video lecture on IIR filter. So in this video, we are going to discuss about transposed transpose form of direct form 2. So before going to that problem, in the last video, we have discussed about the direct form 2 realization. And the problem is h of z is equal to this one, and the output, the block diagram, the signal flow graph or the block diagram of this direct form 2 problem is shown in the figure. And in the left hand side you have poles, and the right hand side you have zeros. Okay, so if I so this is a direct form 2. So if I transpose means if I reverse the flow of information of the direct form 2 realization, it is nothing but a transpose of direct form 2 realizations. So in this you can see, so instead of pole and zero, first on the left hand side you have zeros and poles. This is similar to that of a direct form 1, right? And you have a delay, and you can see the delay is similar to that of the number of delay is similar to that of direct form 2. Okay, so with the help of transpose of direct form 2 realization, we can minimize the finite word length effect. Why? Because the second order block of direct form 2 realization or its transpose are frequently connected together in cascade or parallel combination to produce higher order filter implementation. See, you can see here both the transpose direct form 2 and direct form 2 are canonical in nature. That is, it has a minimum number of delay, right? Since the transpose direct form 2, that is TDF2, the arrangement of this zero is preceding the port in series, which can lead to a better performance with near pole zero cancellation. Since zeros are implemented before the poles, it can reduces the impact of quantization error on the filter's frequency response, especially when the pole and zero are close to the unison. So by implementing the zero first, it can mitigate some of the stability issues that are arises in the direct form 2 due to the accumulation of the quantization error whenever it is particularly used in the fixed point arithmetic. So since we are using only minimum number of delay, so obviously it has an advantage of memory efficiency. So this structure can sometimes allow for more efficient implementation in hardware and software depending on the specific design and target factor. So this is how we have to implement the transpose form of direct form 2 structure. So next let us go for the cascade or series realization. So it is an alternate way to filter realization is to cascade the factorize the h of z in the following form. That is, h of z is constructed like h1 of z, h2 of z, and it's up to hk of z. So where hk of z is chosen to be first order or second order transfer function. Okay, so So hk of z should be b0 plus d1 z power minus 1 divided by 1 plus a1 into z power minus. So when two or more systems are combined in cascade, that is in series, the transfer function of the system can be used to determine a transfer function of the overall function. So h of z, so the example, the transfer function of the two systems h1 of z and h2 of z cascaded together is h of z is equal to h1 of z into h2 of z. So the block diagram of the cascaded or series relation is depicted in the below picture, right? So h of z, h1 of z into h2 of z, you will get so x into x of z, you will get y of z. So first they are asked to, for the same problem, they are asked to realize this second order transfer function for the cascade one. So first this 1 minus the numerator term, you have 1 minus z power minus 2. So it can be written as 1 minus z power minus 1 into 1 plus z power minus 1. So if you bring the 0.5 inside this one, so you will get 0.5 minus 0.5 into z power minus 1 divided by. So this numerator I can write it as 1 plus 0.4 into z power minus 1 and 1 plus 0.9 into z power minus 1. This you can do it with the help of calculator. Okay. So I can write the h1 of z is equal to 0.5 minus 0.5 z power minus 1 divided by 1 plus 0.4 into z power minus 1. Likewise, h2 of z I can write it as 1 plus z power minus 1 divided by 1 plus 0.9 z power minus 1. So these two I'm going to realize with the help of this h1 of z, I'm going to realize with the help of direct form 2. So direct form 2 means you know that the left hand side one is h1 of z and right hand side is h2 of z. So we know the transfer function of h1 of z, right? So what is h1 of z? H1 of z is equal to 1.05 minus 0.5 z power minus 1. So how to draw this one? So 0.5 and minus 0.5 is zeros, right? So first you have to write the pole. So in order to write the pole, so 1 and 0.4, right? So pole you have to interchange the sign. So therefore, if you see the h1 of z in the left hand side, you have to write is minus 0.4 and in the left hand side after z power minus 1 you have to write 0.5 and minus 0.5, right? Similar way you can go for the h2 implementation of h2 of z, right? What is h2 of z? h2 of z is nothing but 1. So this is 1, right? This is 1 and this one is minus 0.9 and above then in the numerator you have 1 and 1. So therefore they are writing like this. Okay. So since it is a multiplication, you have to connect it this one in the series. So what is the advantage of going for the cascade or form of IIR filter? So it gives you several advantages by reducing the sensitivity to the coefficient quantization error, and uh, it will give you better performance for higher order filter compared to the direct form implementation. So here what we are doing, we are breaking down the higher order filter. That is, you can see in the direct form 2, I have the second order filter, right? So we have breakdown into a lower order filter. So therefore, becomes less susceptible to the numerical issues that are arises in the direct form implementation. Okay. So since that this cascaded form will therefore this cascaded form is more robust and it is reliable filtering. So as we know that the stability is crucial for the IIR filter, as unstable filter can produce unbounded output. With the help of this cascaded form, the stability of each second order section, here it is first order, can be monitored independently, and therefore it is easier to ensure the overall stability of the filter. So for the higher order IIR filter, the cascade research is often preferred because it reduces the impact of the quantization error and it simplifies the stability analysis when compared to the direct form implementation. Though the cascade form involves more computation compared to the that of direct form, it simplifies the design process and allows for modularity. So the each section can be designed and it can be implemented independently, and then it is combined in cascade, right? So since the cascaded IIR filter breakdowns the higher order filter into a smaller section, it can lead to a low latency in real-time applications, especially when compared to certain FAR filter implementations.